All right, so we're back to finish the last part of section 4.4. So we're on example 10. So this is the part 2 video. So we're looking at this time a rational function. So we need the domain and the range of this function, and then the domain and range of the inverse, and then the inverse function. So this is one of those that I might find the inverse first. Now I do know the domain. X cannot equal 5. Okay, so I know the domain is from negative infinity to 5, 5 to infinity. Which means I do know the range would be negative infinity to 5, 5 to infinity, right? The domain of the range of the function is the range of the inverse. What I'm not so sure of is what this thing might look like and what the range is. That's kind of hard to do without seeing it. So I don't really want to graph it. So if I find the inverse, then that will help me find the domain of this, which will give me the range of the function. So let's do that. So we're going to write the function down. These are probably the hardest to find the inverse for, but I will tell you that the steps are always the same. It's going to take several steps to get to the answer. So just follow with me on this one, and then you can kind of use those as a guide. All right, so step 1 is just to replace the f of x with y. Okay. Step 2 is to interchange your x for y and your y's for x's. So be careful with that. Make sure you get everything. All right, and now step 3 is to solve for y. So here's where these steps come in, because you got 2 y's in the problem, so that makes that a little bit harder to solve. So these steps are always the same, no matter what rational function you have, okay? So just follow these steps. So the first thing we're going to do is get rid of the y minus 5. Whatever's in your denominator, you're going to multiply it over here with this number, okay? Always. So we don't want to deal with fractions. Okay, so bring the denominator, multiply it over. The next step will always be to distribute. So x times y and x times negative 5. Okay, so get rid of the parentheses and distribute. Now, here's the part that a lot of you kind of forget or skip, but to solve for y, I need all my y terms on the same side, and then I need anything that doesn't have a y on the other side. So I'm going to bring the 2y over here with the xy, and when I move it over, it's going to become negative. And then I'm going to take the negative 5x and move it over here because it doesn't have a y in it. And when I move it over, it will become positive. Okay, so I'm just moving and it's always 2 things usually you're going to have to move. One of the numbers here and one of the numbers goes there. So you just switch them and change their signs. All right, so that's the 3rd step. 4th step is factor out. That's a y. That looks like an x. Sorry about that. I moved the 2y over here, so that's 2y. So the 4th step is to factor out the y. Always, you will factor out the y. Okay. And then the last step is to divide both sides by the factor that you have. So we're going to divide both sides by x minus 2. So we end up with 5x plus 1 over x minus 2. And now you solve for y. So the whole point of this is you only need one y, and you only can get one y by factoring it out. All right, and then you're going to write your inverse notation, step 4, which is 5x plus 1 over x minus 2. All right, so there's the inverse. So now I can finish my questions up here because this is easy. I know the domain of this is x can't equal 2. So that's the domain of the inverse, that x cannot be 2, which automatically means that that's the range of the function. So I could do that without even graphing it or looking at it. So it's kind of neat that that works that way. Okay, so like I said, you can answer these any way you can. Sometimes you know them all before you even do the inverse, and sometimes you don't. Okay? All right. Couple more. And then we'll do one last thing, a couple more pages. All right, so this is just a linear function. Okay? This one says give 4 points that are on the inverse. All right, so let's just look at over here. Let's do a couple points for x and y on function. So we're going to do 3x minus 2. Okay, now you can use your calculator for this, but this one's pretty straightforward. So let's pick some numbers for x. 0, 1, 2, 3. Plug those in here. So when x is 0, 0 times 3 is 0, minus 2 is negative 2. When x is 1, 3 times 1 is 3, minus 2 is 1. When when x is 2, 3 times 2 is 6, minus 2 is 4, and 3 times 3 is 9, minus 2 is 7. All right, so these are ordered pairs on the function, so I can now write 4 points on the inverse. I'm just going to flip those around. Negative 2, 0, 1, 1, 4, 2, 7, 3. Okay, so that's as easy as that, and you can go to your calculator and get your points off your table as well. All right, this is a linear function. It's a line, right, that goes up. So the domain is all real numbers. So is the range. So that's easy enough. Same here. All right, find the inverse. So here's our function. Step 1, change f of x to y. Step 2, switch the x and the y. Step 3, solve for y. So add 2 to both sides and divide by 3. And you could write that as 1/3 or x over 3 plus 2/3. That's fine. Same thing. And then step 4 is your inverse notation. So that equals x plus 2 over 3. Okay? All right, example 12 is one more radical. All right, so 4 points on here. Let's go back and use the table just to make sure you remember where that is. I can't remember if I showed you that or not. So let's get rid of some of these guys. All right, so let's put in negative square root of x plus 2. Make sure you arrow outside of the radical. Okay. Now to go to your table, remember it's second graph. And just don't remember if I showed you this or not. All right. Now remember, our domain, before I do this, the domain is what's under the radical has to be greater than or equal to 0. So x has to be greater than or equal to 0. So our domain is from 0 to infinity, which again is the range of the inverse, right? Not so sure about the range, so, all right, so I know that I have to pick numbers greater than or equal to 0, so that's why there's errors up there. So I've got 0, 2, so on the inverse would be 2, 0, right? I'm flipping them around. 1, 1. Let's find some more that are whole numbers. So 4 zeros on the function, so that would be 0, 4. And let's find one more that looks nice. 9, negative 1, so negative 1, 9. Okay, so there's 4 points on the inverse. You can use your calculator, that's fine. All right, so I don't know the domain of the inverse or the range of the function unless I graph this, which we could graph, but let's say we don't want to graph it. So let's find the inverse, okay? So function, negative square root of x plus 2. Let's do our 4 steps. So 1 is to replace that with y. 2 is to switch your x and your y. 3 is to solve for y, so move the 2 over. Now we've got to divide by negative 1, or multiply both sides by negative 1, so that's going to change our signs. Then we're going to square both sides. And now we're done. So the inverse notation is negative x plus 2 squared. Okay? All right. So because of that negative sign, remember that's going to throw us off. We're going to go... That's kind of a hard one. We haven't really done ones when they're written like that. So I'm going to graph this just to kind of help us out. So I've got to factor that out. And we didn't go over those, and I wouldn't give you one of those on transformation. So let's just kind of look at this. So negative x plus 2, because it's going to flip it where you don't think it's going to happen. So here's the graph. So let's look at that. All right. So there's the parabola. So it went right to, okay, now remember our domain We got to start at 0. Okay. All right, so if we look at this, we're just doing this side of it. Okay. So look at your domain for that. So that just started at 2. Okay. 2 to infinity, because we can't use this side over here. So 2 to infinity would be the domain, and 2 to infinity. Okay. All right. And you know, you could do this graph. This is the square root function. We reflect this over the, think about it, this is good transformation practice. This reflects over the x-axis, and then we're going to go up 2. So here's the parent function. So if we flip it over here, and then we go up 2, then, okay, so you can see that's the graph, and then we have this part over here, which would be, that would be that line y over x that's there. Okay. All right. All right. Okay, so let's move on to part C. So here's the last page, and this is just to determine if two functions are inverses of one another. So it's a composition problem. So for you to be able to show that two functions are inverses, you have to show that the composition of the two functions gives you the value of x, and only x, okay? So you have to prove that by showing that. So if you look at these examples, it says determine if these are inverses, and then if they are, then find f of g of 4. All right, so we have to do f of g of x, which remember is the same thing as that. So we're going to take this function and put it in for that x. Okay, so 2 times x minus 6 over 2 plus 6. And we have to prove that we're going to get x. That's what we need to do. All right, so these 2's are going to cancel. So that's nice. So we end up with x minus 6 plus 6. Now the 6's will cancel. So we just showed that we got x. Now, typically you have to do it both ways, but if one way works, the other way will always work. So unless you ask to show it both ways, I'm happy with just you doing it one time. All right, so now we're supposed to find f of g of 4. Okay? All right. So remember, these are inverses, so just think of what's happening. I'm going to plug 4 into its inverse and then get the answer. I should get 4 again, but let's make sure that happens. All right, so g of 4. If I put 4 in here, 4 minus 6 is negative 2 divided by 2 is negative 1. So that's f of negative 1. Now, if I put negative 1 in here, 2 times negative 1 is negative 2 plus 6 is 4. So look at that. So when you have inverse functions and you plug in one number into one and then back into the other, you're going to get back what you started with. Okay, that's what that says. So you don't really even have to work this out. All right, let's look at example 14. Determine if these guys are inverses. So again, we're going to find f of g of x, which is f of g of x, if you want to write it that way. So, all right, so we're going to put this function inside of this function, okay? So that's 3 over, and then 2 times, and then instead of this x, you're going to put this function. So negative 3 over 2x, like that. All right, so again, these x's the 2's cancel. So now we have 3 over negative 3 over x. So that's 3 times, and then we're going to flip this. So 3's do cancel, but we end up with negative x. So that these are not inverse functions. You have to get x. Okay? All right. Last one. Given this graph below, let's answer these questions. All right, so what is the domain of the inverse? What is the range of the inverse? What is the y-intercept of the inverse? So remember, I don't have the inverse, but it doesn't matter because the domain of the inverse is the range of this function. The range of the inverse is the domain of this function. So look at your domain of this. Negative 4 to 3. So negative 4 to 3 would be the range of the inverse. What's the range of this function? Well, that goes from negative 3 to 4, negative 3 to 4, so that would be the domain of the inverse. Okay, so they flip. So the y-intercept of the inverse would be the x-intercept of this graph. So the x-intercept is right here, right, because that's the point negative 1, 0. So the y-intercept would be 0, negative 1, which would be down here. Oop. Okay, they always flip. All right, what's f inverse of 0? So again, this is x on the inverse, which means it's y on the original function. So go to where y is 0, okay, which is right here. So that would be 2. All right, again, this is x on the inverse, so it's y here. Go to where y is 2. That's your value, so negative 2. Okay, same thing, go to y is negative 2. So that's 0, negative 2, so that would be 0. Go to where y is 3. Find that x value, which is negative 3. And go to where y is 4, way up here, so that x value is negative 4. Okay? So you don't have to graph the inverse in order to find inverse answers. Now, it's perfectly fine if you wanted to do what we did on that first example way back when and plot these so that you see the inverse, but you don't have to if you remember that you're just flipping your numbers around. Okay? All right, so that does it for this section. So finish your homework. I hope you've started reviewing for your test that's coming up. Email me if you have any questions, and have a good rest of the day.